Thanks for being here. Thanks for joining the Mighty Mainframe Conference. I think it's a very, very nice thing to do. To start with, I show you some real architecture from my hometown in Stuttgart. That is the old post direction, and actually under it we construct a new train station at the moment. But I mean, in Stuttgart usually they don't take preservation rights very serious, but with this building they wanted to make a point. So they forced engineers to actually not deconstruct it and reconstruct it again. They forced them to actually keep it alive. And what they did is they actually put these spaghetti-like foundations under it so that you can actually build something under it and then later on fill it with concrete and have it there. I mean, I find it pretty amazing actually. And a little bit like this foundation where this little building stands on, our mainframe is the foundation of most of what we do still today. So we say here the civilization heavily relies on IBM Z today. Most critical systems are powered by the stability of IBM Z. I brought some marketing numbers. That's the only marketing chart you get. We say 70% of our world transactions, of world transaction by value are running on Z, and 77 of the 100 top banks. Usually students will then ask, what do the other 23 do? Of course you can do IT everywhere. I mean, also on x86 systems, that's not a problem. The only thing that I would disclaim before, even they do it on x86, they will probably have a monolith. There's nothing wrong with monolith. You could have asked this morning Sam Newman about it. So to get a second opinion, it's fine to have a monolith. But we will come to that. Otherwise, it's just we are growing. Everything's good. But it is 2024. Do you know what that means?
60 years.
60 years of mainframe computing. That's a little bit how it started with computing. That's the ENIAC machine. That's older, exactly. That's right. That's how we started with computing, not with Z. Then we had some machines looking a little bit like this, the 704. And some others. Unfortunately, the Beamer, all my pictures were not that good. And then there was a big problem, because when we built computers back then, they were not compatible to each other. So if you buy a new computer, you have to hold new punch cards, everything was different, you had to redo all your applications. Because in some magic wisdom, every architect of a computer system decided, I put the plus option on the first. The other said, I want to have the minus on the first. So you had to recode, because the base instruction set changed. And so the other cool thing is, what was 2 days ago? May the 4th be with you. I thought of some mainframe Star Wars alignments. So basically the mainframe was kind of a new hope that came to rescue the world of computing. Because at the time, as I said, it was quite complicated. If you had a new computer, you had to redo everything. That was annoying. So we put some very clever people, especially Thomas Watson Jr., put them in force to actually redo what computing meant. And out of it came this thing called the S360. That's why we had this fancy picture. I like this because that's Grand Central in New York. And actually there was a separate track where people went to Poughkeepsie for the press conference. Just imagine that. We have been the apple of times. 2 days we are a little less interesting marketing-wise, I would say. Also, we had some very cool advertisement. I like that one. On April 7th, 1964, the entire concept of computers changed. That was bold, not like today. Oh, you can do something with Watson. Maybe not, we don't care. So basically that what happened at the time was this $5 billion gamble. That IBM really invested very heavily in that system. And I just realized, beside the wrong font, it also is German. Because I thought, like, coming here, we see also very much mountains around us. The design criteria of IBM Z. So it's, even if it's German, I think you get it. And we had a very few things that are still remain true today. First off, we want to be reliable. So if you ever go mountaineering, you want to have reliable equipment. And that's the same still true for the mainframe. It is, as itself, very reliant. We also did something when it comes to availability. I said we talked about high availability there, because you don't want to just have something that is very reliant, you also want to have it redundant, because sometimes your thing goes wrong. So availability is important. I really like that piece of engineering, aside of computing, to actually give new fuel to an aircraft while it is flying. I find that very impressive, but that is kind of technology-wise what we also do with mainframes. We can service it while it is going. We can service it while it is actually running. We can put in new CPUs while this whole thing is running. That's pretty cool. Also another thing we do pretty well, something I'm not that famous for, security. I'm more famous for security, no, Toby, because if you turn off security, everything becomes very easy. You don't need to worry about permission rights. But of course, I'm very happy that a lot of people love security and they take it more serious than me. And this one thing that is very important for mainframe is compatibility. Who remember this guy? The universal business adapter. There you can plug in your mainframe. That was what he was pointing to when he said you can plug in your mainframe. So the bad thing with this thing is, the good thing is we have 60 years of compatibility. The bad thing is we have 60 years of compatibility. All of you never had to change. We were all happy, it all worked, all the time, everything is good. So we had basically since the 60s not the real need to change, or very few moments. So we forced you, for example, when we went off from Kix macro level, you had to change. But mostly I think we kept your applications okay. Not how you had to interact, that might change. ISPF came along, ISPF is not in favor that much anymore, things change, but the application itself can still run. So then a bad thing happened in the 80s. As in every good trilogy, we have the second part. The Empire Strikes Back. So basically the distributed systems came around and they created a little bit of a fuss. Do you remember what that advertisement was from? Macintosh. That was the Macintosh coming and destroying IBM. Woo, finally. But actually what happened was complexity rose quite a lot in that times because everyone can have its own computer, so you can do your own stuff with it. The other thing that is very interesting, there was a big German computing fair called the CeBIT. Do you remember that? So in the 90s, there was an advertisement looked like this. It says, 30 years ago, she was full in trend, exactly like your mainframe. Who that doesn't know it wants to have a guess who advertised this at CeBIT? That's a perfect sound for the thinking. What? Close, a little bit more hardware oriented. Sun Microsystems. Oh, where's Sun today? So that went well, that statement. I mean, a lot of people do prediction when it comes to mainframe. Mostly they fail. I mean, the most famous one is Stuart Alsop that says last mainframe will be unplugged 1996. But he had fun. Was actually kind of a guy that took the fun. He actually ate his own letters, so he ate some chocolate bars in the name of it.
By the way, the CeBIT vanished as well.
And the CeBIT has gone as well, yeah. So basically everything was broken down except of the mainframe. Probably this lady is still alive as well. It was just only the guys that did the marketing that failed. So in the end, the return of the mainframe, that's where we are today. But not without problems. As we know, there are other parts to the trilogy, but let's stick with the original one. So I will not bore you with part 9, 11, and 12. You can have your own opinions on it. So we still keep some things the same. We still do high availability very good. Actually, we don't do that. Because that, I mean, at first it's a fake, but of course, that's very much too simple. We don't exchange tires. We actually exchange the whole engine while driving. I learned that you can do that in ships. I didn't know. I didn't find a picture of it. That picture is much more funny. So we stick with that one. We also improved a lot in high availability. So as we had this morning at breakfast, when some people started their lives, they still had an outage with their mainframes every day. That was kind of a normal thing. It was not as elaborated as it is today. Whereas today, it's really hard. If you have a good working sysplex, with metro mirroring of the data and all this stuff, it's very hard to really break it. You need to, of course, if you want to, you can, easily, but if you make it right, it is hard by accident to break a mainframe. So we really improved on that one. We also improved a lot on security and on encryption. It's always very funny. I have a colleague, Rita. She always used to say, a lot of people worry these days about quantum secure encryption. Someone does? Someone worries about that? Most people that worry don't encrypt anything. So if you don't do that, don't worry about quantum encryption. You can start already today, and with Z you can even then start with quantum safe encryption. So that is also good. We are a quite sustainable platform. Running Z is actually very efficient. If you fill it up, if you just run some Minecraft on it, then it's boring. But if you really run workload on it, it is a very sustainable platform because we are okay with running up to 95, 99% of utilization. That is different on x86 boxes. We also are, and we haven't been good for that at the beginning of the 90s and later on, we are a very performant machine, 5.2 gigahertz. That is not what you get in your usual Intel environment. You don't need that usually, but if you need it, you are very happy that you get that performance. So now you had all the happy talk. I might nearly close half to my talk, but that was not what we want to talk about. We have some problems, do we? We have your application. So when people say we want to modernize the mainframe, IBM usually refuses and says, whoop, 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 we have a very modern machine. It has 7 nanometer processors, it has the fanciest RAM you can have, 40 terabytes of it, everything is cool, the mainframe is modern. So the hardware itself is not too bad. The applications that will run on it are a little bit entangled over the years. It was not because 20 years ago someone woke up in the morning and said, today I do shitty programming. That was not what happened. It just eroded over time. So when people started to build applications, they had a good vision in mind. They had a good idea how it should be separated, how the encapsulation should work. All of this was good. They had some limits. At the time they designed the application, when they did it, for example, in the 70s, there was not that much storage around. So they tried to be very efficient with storage. You don't need to be very efficient with 40 terabytes of storage anymore, but at the time you better were. So people did some stuff you wouldn't do today anymore. But also over time, someone said, oh, there's an error in your code. I could just go there and flip the bit, then we are good. And everyone said, that's not good. That's not what you should do. Never mess around with anyone else's storage. And then everyone said, we need to be fast, just do it. You can fix it later. And as my grandma always used to say, if you don't have the money to do it right, you will not have the money to do it twice. So of course, all of these problems still are in our code. We never fixed it because we first said, yeah, we do it later. And then we said, we want to get rid of the mainframe. And then we said, it's so complicated now. It's so hard to find someone that understands COBOL. So we still have that mess. And we need to work on that. There are some good reasons why you want to act. There are some really good reasons why you want to act. And the best one is because your business changes. Your business really changes every day. And it does so for good and for better reasons. Sometimes it's regulation, that's annoying. You have to do something because the regulator comes and says, oh, you now have to do DORA. And everyone's like, oh, how should I do that? But also sometimes it's good because you make more business, something you haven't done before. Like, for example, when you're a retailer, now everyone is ordering to their homes and stuff like that. So you can do things. The other one we already shortly had, technical debt. Over the years, so SIM cards and micro SIMs these days would be considered as technical debt, even though they were a cool concept, but they're not around anymore. It's all pretty much fixed in the system. So you sometimes have technical debt. You want to get rid of that, and you want to put some work into that. I mean, I'm just a keynote, so I don't tell you exactly how. That will the people later on do. But I give you some ideas. So technical debt is a real problem. And it will remain a problem. So whoever thinks, if I build now something cloud native, I'm safe to not have technical debt anymore, you even generate more technical debt every day. Every morning we get up, we generate technical debt. And that's fine. That's because we're human. We will make errors, we will have wrong assumptions, we will have time pressure. All of this is fine. The big problem is that we don't deal with it. Just imagine you make debts in money every day and you would not take care of it. Your credit card company at one point says, you don't get any money more. So we have to actually get rid of that technical debt. That's something we all need to work on. And as I said before, security is a thing. When you recently read some things about the Microsoft cloud, for example, you understand they have problems in the cloud too. But not just in the cloud they have problems, we all have problems. You maybe heard of this exact bug we just nearly destroyed the whole internet with. There are good reasons why you have to be careful. And let's be clear, you can't say it's security by obscurity, no one knows how the mainframe works. Everyone knows that that these machines is where the money is. So actually very professional players will work on that. And you can be sure they will be able to learn mainframe. So security by obscurity, a very bad concept. You need to work on that too. Then we have this annoying thing called costs. Everyone runs around and says, the mainframe is so expensive. Even IBMers usually say, we know it's so expensive, but it's a good machine. I'm not even sure if the statement at all is true. I wouldn't even agree to that. I would say it's very cost efficient. It's probably even cheaper to run stuff on mainframes than on other platforms. Because then they come out and say, but an x86 server only costs €8 or something. It's like, What does that mean? I mean, this is a machine that is high available. Usually you have good backup concepts. You have concepts that are different regions involving, so you have GDPS and stuff like that. So it is, of course, costing a lot more than a single instance running a database to run a 16-way DB2 with data sharing. That's part of the game, fair enough. But you get a lot more things, and you have to worry a lot less in your applications, as we will see in a second. And then my favorite, as you heard this morning, missing skill. People sitting in their offices complaining that they can't find anyone in their office that understands mainframe. You have to go out, you have to talk to people, you have to give them a good reason why they want to work for you, because you run the banking system in all of Europe, because you are a lead insurer, you are part of the government, you take your pension funds and stuff like that. People are willing to have a purposeful, we saw that on Sam Newman's charts this morning, he talked about purpose, you want to have a purpose. We often offer a good purpose. Most of the cloud native startup things are not as much of purpose. I mean, they will probably dissolve over time. Whereas here you can be very safe, it is there. And we have some other problem with skill. Do you know what that is? That's a demography curve of Germany. So it will be German, because it's from the official German status. Basically it says the red line was 1990, and the blue line is 2021. So you see, basically, it moves up, what is it, 30 years. You cannot really discuss with statistics. Sometimes people try to argue, and then they say, but here it is much smaller than it used to be. Yes, people break. After they become 60, they get a little bit more breaky, so they can be spoiled and not work anymore. And so that's especially funny is when you look here, male don't do well. That's mostly because they have very stupid decisions, like running around, putting a mattress around and fight with a, don't know, with an nose or something. It's a very stupid idea. So anyways, women usually make it a little longer, but even there, they will break. So you can't rely on people working in their retirement. But you also have the issue that we have less people. So the integral of red was bigger than the integral of blue. So now we can think ourselves, can we really afford to replace everything in IT we already have today? While at the same time we build new cars. Who wants to have a guess how many chips are in a modern Mercedes-Benz? Give a guess. Guessing, the good thing with guessing is you can't go wrong. It's just 50 to 100. It's 1,000. So you meet in the kind of in the middle. So it's 1,000 and 100 million lines of code. This code in every new BMW, in every new Mercedes, in every new Audi, or whatever you have, probably even more in Tesla. Yeah, there are also other cars, of course. I only remember the German ones, being good German. But you can have the other ones as well. They will have the same amount of code. You can go to a Skoda. Skoda will have the same because it's basically VW code. But anyways, so there we go. So anyways, we have that issue. We generate more IT every day. Just look in here. The cameras are not something analog anymore. The computers, everything we see is very complicated technology. And we generate more and more of it. And now people say, there were people that built the core banking systems of our today's world. We could basically, with some effort, repair it. So when you, I don't know, what is the most expensive city in, is it Zagreb? Probably the most expensive city in Croatia. Yep. So when you inherit a flat in the middle of Zagreb, was built in the 70s, so it has this very nice yellow bathroom or something, whatever people in the 70s found fancy. You don't like that. But you would not run around and say, oh, I had legacy. It's so annoying. I just basically don't want it. You would, of course, say, thank you very much for inheriting me a flat in the middle of Zagreb. Let's get rid of that yellow bathroom. You fix the bathroom, you're happy. When we see mainframe software, people look at it and say, there's this one thing I don't like. Yeah, let's just throw it away and you write it in cloud native. And now think, we are less people. The people that understand today's business are going to retire. Are we really willing to spend 10, 20 years to rebuild everything we have because we don't like the programming language anymore? Because in 20 years' time, guess what? Whatever we consider most modern and fancy today, someone else will come and say, let's rebuild it in something else. That is not sustainable. We can't do that as a society, so it will not work. So please avoid some anti-patterns. The biggest one you can already guess is never forget to ask why. Why do we want to redo something? That is usually a very complicated question to ask, because when you then ask people and say, yeah, but it's old, or something like that, they come up with strange things. They don't really know why. You believe in magic or silver bullets. There's actually a book written in the 70s by Fred Brooks who said, there are no magic bullets. It's called The Mythical Man Months. You will see it in my reading list later on that I give to you if you have time in summer. But it is a good book. In 72 was written. If you read it now, you will be so disappointed, because you read it and think like, well done. In 50 years' time, we haven't learned a thing. So the same problems he described there are still, of course, on a different level, totally applicable to our industry today. Then it's old. That's Oxford. You wouldn't go to Oxford and say, huh, that's old, let's tear it all down and make modern architecture, whatever that will be. So you don't destroy things just because they are old. And it is not the whole thing that is old. As I told you before, the mainframe is a very modern machine. It's a very modern concept, so it's nothing wrong with it. But sometimes, for example, you don't want to have single glass windows anymore. That's not a thing. That's even for old buildings, it's good to replace them, because heating is expensive, oil and gas gets expensive. Fix the window. Don't tear the building down. You have the yellow bathroom. Fix the bathroom. Make it whatever is fancy today. Maybe white. Timeless. But anyways, you can decide whatever you want. Fix that. Fix the problems you have, not the ones you think. And the most annoying thing is, everyone does it. Follow the mainstream. 1,000 flies can't go wrong. The end of our stomach must be nice. So we need to fix these things, and we really need to think on how to do this. So the most annoying thing these days happens, and if you really listen to Sam, it could be seen as a critique on Sam Newman. He said building microservices is a good thing. I don't mind. But the thing is that most people look at these things and say, who is doing it well? Spotify, Netflix, Amazon, Google. I want to be like them. But I'm a bank. I'm an insurance company. It's so annoying. Why can't I be like those guys? And most people then try, and in between they notice there is something very different between the right and the left side. Someone wants to have a guess? Very different business model. They have non-transactional workload. They don't care. If you order something at Amazon and you didn't order it, or they send you something, they will not tell you, oh, send it back, because we have to repackage it and send it to the person that belongs to. They say just throw it in a bin. It's much cheaper than if you would send it back. So things are really different here. There's one, meanwhile there are two. We forget about Google Pay. But Google had a very transactional use case called the advertisement. They actually invented something, if you look at it, that looks a lot like DB2 with data sharing, Google Spanner, but they used atom clocks for it. It's not that easy, not everyone can. So there are good reasons why we are different. We are also normally having good growth. Is Tom in the room? Yeah. Normally I would say at this point in time, what bank will have tomorrow twice as much customers as today? That held true for a long time, and then Credit Suisse and UBS did their thing. So there are these very few exceptional cases when you have double the amount of work tomorrow, but you shouldn't build your systems for that, because it's very unlikely. So don't do that. So we are different.
So
yes.
You forgot regulations in that.
Regulations? Yes, of course you can. I'm just focusing on technical stuff.
They're not regulated.
That is definitely true. I'm just focusing on the technical stuff. You can, of course, go there. You can, of course, go to the security requirements, a lot of other reasons too. Just going at the plain and simple stuff. So that is other people saying. So basically, if you're trying to split a monolith that is very bad designed into a microservice architecture that is still bad designed, you have this like the same amount of weight afterwards, and it's not worth the effort. Actually, it becomes more crappy after, because you have TCP/IP. That's usually not a performance nor a security feature. So architect Clippy said, if you have a poorly structured monolith, you don't want to convert it into poorly structured microservices. Simon Brown, I really think he's a great mind. And also Sam Newman, as I said, I didn't have his picture there, but he says basically the same thing. Martin Fowler, everyone says a good monolith is far better than a shitty microservice. So think about it. And then last year, beginning of last year, it was amazing. The Pope basically said being a Protestant is fine. Amazon came around saying, Scaling the audio-video monitoring services was reduced by 90% in cost. From moving from a distributed microservice architecture to a monolith. Oh, come on. Even Amazon couldn't make it true. So there are some good reasons. You can read it up. It's in the internet. It's in the Prime Tech blog. So you can look it up. There are good reasons why you want to have both architectures. And now, being a good technical person, I at least want to end with a little bit of technical content, even though I won't steal the thunder of everything that's later on. But that is a good architecture diagram. That is what you can start with. You don't need to decide. You sometimes have the feeling you need to decide, do I want microservices or a monolith? Java or COBOL? You don't need to decide. You can have both. That's a good thing in IT technology. And for whatever reason we are, as humans, have this feeling we always need to decide, we don't. We can have both. We need to understand where and when. So we might have today a big COBOL monolith that it's not in perfect shape. We might need to transform it into something better suitable for the task. We need to get rid of that code. Usually most of you carry around 30% of that code. No one cleans it up because why would I? I mean, they hopefully should, but at the moment no one did, because why would you? I had a customer, you had to pay if you want to have an old program deleted. What a stupid incentive is that? Of course, no one ever deleted a program, even the test programs, everything stays there. You could have a new one for free, but you had to pay if you want to delete it. That's a very stupid incentive. Anyways, they now have to clean it up as well. You maybe don't need a big DB2 that does everything. You can even refactor it in smaller DB2 instances. There's nothing wrong with it. You can even use distributed data technologies. That's not a problem. Have both. It's fine. Discuss OpenShift. I mean, people love OpenShift. People want to have microservices. OpenShift can also run on Z. So it's not a problem to also run that there. You saw that in Rosalind's charts if you've been there. We do that ourselves. You can even run the more modern stuff on Z. You can run Linux on Z. You don't even have to run ZOS, even though I would say there's nothing wrong with ZOS. A lot of people think, oh, you have to be Linux. Everything's fine in Linux. Not everything is there cool as well. So you have problems in Linux as well, but you can run it side by side with ZOS. The other thing, that's what I will close with. Do you remember that chart? Try to get, and that's what, when people say, we just use AI. We tell the AI what to do. Yeah, that's exactly the problem. You can't. That's what we deal with for the last 40 years, that humans are not having the ability to explain what they want from us. So the most closest thing we found were programming languages, where we could tell a computer relatively safe what it should do. So we now say, just talk to your large language model and let it produce something. It will produce shit, because you can't really tell it and specify it. So we explained the wrong thing. The project leader said, oh, let's go cheap, make it halfway. The analyst said, but you can't swing anymore, so let's cut the tree. The programmer said, I will not cut the tree. The beta tester killed himself. The business consultant said, oh, it's so fabulous. Documentation will be done in future. Operation didn't start half of it. The bill was amazing. Support, let's forget about that. Advertising was great, and you wanted to have that swing. The thing is now, we are not up there. We are here. We have the swing, but maybe the rope is a little rotten. So what most people do now, they say the rope is rotten, we need to re-go through that cycle. You can also just replace the rope. And that is what I want to tell you with modernization is important, but you don't need to throw everything away. So we love this OpenShift stuff, but we also love transactional system and we love IBM Z. Even that is the old machine. Just want to include everyone so you can also still have a Z15. You don't need to have a Z15. I can't imagine anyone coming out of college saying, for the rest of my life, I want to do additions, subtractions, very rarely a multiply, and surely nearly nowhere a divide. That is not fun. Let's be lucky that someone wrote core banking systems, because they were banking people. They knew how to do it. It was not always the prettiest code, but it worked correctly. Now we have information technology students. They write pretty code, but totally wrong business-wise, but it's pretty code, amazing. So let's think if we really want to do it like that. Otherwise, here the promised reading list. You want to read that. If you think about good design, read Eric Evans. It's dry. There are newer versions, but I haven't found something that's really good. Same is true for design patterns, Gang of Four. It's not nicely to read anymore, but there is a very nice version of it. It has nice comics, you can read that. Thinking Fast and Slow is always good. when we make decisions, we should always wait for the thinking slow, not for the fast one. And Paul Watzlawick, that's a German one. I think it's translated as well. The Tutorial to Being Unhappy. It's generally a very good book. Thank you very much, and enjoy the rest of the conference.